All right, Math 1, here's part 2 of the 3.6 lesson. The first video might have left you thinking, I'm not really sure what's going on here. That's okay. Let's just see a few examples, and maybe things will piece together as we move forward. So our first example, the absolute value of 6x plus 7 is equal to 1. If you recall in the first video, we basically took into account the fact that the absolute value of positive 1 equals 1, right? And the absolute value of negative 1 equals 1. So what this demonstrates here is that there's two solutions for an absolute value quantity equaling 1. The first solution is when you set the inside of the bars equal to the inside of the bars there. So 6x plus 1 is equal to 1. Or 6x plus 1 can equal the inside of these bars, negative 1. So once you map those two pieces out, just solve them. So there's one of our solutions. Here's the second solution. This is the same as negative 4/3 because you can cut the top and bottom in half, which is negative 1 1/3. So it's either x equals negative 1 or x equals negative 1 1/3. Now it says be able to solve, check, graph. Let's do that. Let's see, I think we have some space here. We don't need a whole lot of space. Negative 1 and negative 1/3 are right next to each other on the number line. So I'm going to go 0, 1, negative 1, negative 2. We're going to put a closed dot at negative 1 and a closed dot at negative 1 1/3. And then interpret the solution. Well, my interpretation of the solution is that the solution to this equation is x equals negative 1 and x equals negative 1 1/3. There's the graphing interpretation of it. Not much more I got to say about it. Let's try number 2. So what happens when the absolute value bars are not directly on one side? Like what happens when the bars are not by themselves? Well, you're supposed to get the bars by themselves. So absolute value bars have to be isolated. So we first, before we start splitting it into any two parts, we need to say, get the absolute value bars by themselves, or get this quantity by itself. So what we would do is we would say, I'm going to subtract 5 because, this is multiplication here. When you put a number directly on the outside of the absolute value bars, you are implying multiplications going on. So I can undo this plus 5 first by just subtracting it from both sides. So that leaves me with negative 4 times the absolute value of 3x minus 4 is equal to 1 minus 5, which is negative 4. All right, now this can be kind of tricky, all right, because you're used to getting rid of parentheses, so you're like, well, let's get rid of the bars. It's not the distributive property here. What we can do is we can say, I can undo this multiplication through dividing this quantity by negative 4. The stuff inside the bars will not divide the negative 4. But negative 4 divided by negative 4 is 1, which is what we want. We want a clean quantity on the outside of the bars. So I would divide the right-hand side also by negative 4. So negative 4 divided by negative 4 is 1, and we put that in front of the absolute value bars. Negative 4 divided by negative 4 over here is also 1. So you need to do that step first. Get the absolute value quantity by itself before you solve anything. The next move is just like this. I have bars on the left, a constant on the right. So we're saying the absolute value of what gives us 1? Well, we just saw it right here. The absolute value of 3x minus 4, therefore, equals 1. Or the absolute value of 3x minus 4 equals the absolute value of negative 1. So all I'm doing is I'm saying, hey, these are the two quantities that the bars can equal, so I'm setting them equal to the stuff inside the bars. All right. Solve these two equations. Just pause the video and try that on your own. Okay, you should have added 4 to both sides here. And then divided by 3. X equals 1 2/3 is what that comes out to be. The second one, add 4, divide by 3 again. Hopefully you guys can see that. I know it's getting kind of convoluted. I think you can see that. X equals 1. So those are our two solutions. 1 and 1 2/3. So what would that graph look like on a number line? Well, we would just maybe I'll go by a thirds this time. 1/3, 2/3, 3/3, 4/3, 5/3. 1/3, 2/3, 3/3, 4/3, 5/3. And, put a point here and put a point there. Notice, I'm not shading anything. This isn't an inequality. All right, and that leads us to compound inequalities. So I'm not sure if I should stop the video or keep going. Let's keep going with it. Because these are slightly different. Clearly, because we've got inequalities. So what are we supposed to make of this less than or equal to sign? Well, I guess think about this. The stuff inside the bars represents a distance from 0. So maybe it's probably good to map it out like this. This is saying the distance 2x minus 9 is from 0 on the number line, and I know I'm getting kind of wordy here, is less than or equal to 1. So what does that mean? Well, if we were to draw a number line, to be less than or equal to 1 is to say we're basically setting a boundary of you can't go farther than 1 from the 0 this way, and you can't go farther than 0 from 1 this way. So what does that look like if you shaded from here to there? It looks like an and situation if it's a regular and situation. So here's what you do. You say, this is going to be an and situation right away. When you see that less than or equal to, it's saying I've got a very limited space. Got a very limited space. So if you see less than, or if you see less than or equal to, these are and situations for inequalities. For absolute value inequalities. So the question becomes, how do we deal with this symbol? Well, you got 2x minus 9 is less than or equal to 1. But because it's an inequality and not an equation, we have to make one slight adjustment. When we rewrite our second expression with not 1, but negative 1, this must flip from less than or equal to greater than or equal to. I think I'll just explain that one in class because it requires just I don't know. I didn't really prepare to explain it just now in this video. So, I'll explain that in class. But bottom line is these are the two inequalities that come about from a absolute value inequality, and then you just solve them. X is less than or equal to 5. That's the first part. The second part, x is greater than or equal to 4. So if we think about what that graph would look like, 1, 2, 3, 4, 5, 6. My 5 is going left on the number line. My 4 is going right on the number line. And means graph what they share. They only share the stuff between. So that's the interpretation of my solution. Here's me solving it. I had to split it up into these two parts. Less than is and for absolute value inequalities. And yeah, I just solved it like normal. It's not too tough, but understanding the concept is a little bit wonky. Okay, let's try number 4. Number 4 starts out as greater than, which means this is saying the distance 3 minus 2x is from 0 on the number line bigger than 7. It's greater than 7. So when you think about a distance from 0 that's greater than 7, it's like you're at least 7 units from 0 on the number line, and then you keep getting bigger that way. Okay? Or you're at least 7 units this way, and you keep getting bigger that way. It's like you're at least, here's 0, here's 7, you're at least that far away. Or if you go 7 this way, it's at least 7 that way. So this looks like a regular or statement, and that's exactly what greater than gives us. Greater than or equal to, or situations for absolute value inequalities I'm sorry. That's what we're doing. We're choosing or when it's instantly greater than, or greater than or equal to. So, here's what happens. We split it in two parts, 3 minus 2x, that's going to be greater than 7. Or for the greater than, we are going to say 3 minus 2x, we have negative 7 on the right. Instead of greater than, it's going to flip. It's going to be less than now. And again, I'll explain that as best I can in class. All right, solve it like you normally would. So minus 3 from both sides, you get negative 2x is greater than 4. Divide by that negative, that's going to flip the direction of the inequality symbol. X is less than negative 2. Subtract 3 from both sides over here. Negative 2x is less than negative 10. Divide by a negative, that flips the direction of this inequality symbol. And here's your solution. X is less than negative 2 or x is greater than 5. It's a regular or statement. So you just graph it as is and you're done. Final answer right there. All right, now I wanted to highlight a few special cases with you guys. And then we'll call it a day with this video. We're already pushing 15 minutes, so I realize I am pushing the boundaries of what you guys are willing to endure. All right, so number 5 example. Yeah, this is a tricky case. When is this, and I'm going to put distance in quotes, greater than or equal to -8? Well, I think what I've established, and hopefully you guys are getting that I've established this, is that distance is always a positive value. Absolute value forces things positive. So the absolute value of anything must be positive. I guess it could be 0 too, but let's just forget about that scenario right here. So the question is, when is a positive number greater than or equal to a -8? Everywhere. This is always true because of the negative and it's greater than. So if you see absolute values are greater than or equal to negative numbers, you got to say, yeah, that's true, always. So the answer would be all real numbers. Check out number 6. Same question, except when is the distance less than -5? Well, the absolute value of anything is still positive. That's just a fact. So, when is a positive number less than -5? Well, all positive numbers are greater than -5. This is never true. All right, so if it's never true, this is just instantly going to be a no solution situation. And you don't have to do any computing at all. All right, last one. Hopefully we can keep this thing under 20. All right, so I don't have the bars by themselves. I got to do that move first. I divide by the quantity on the outside. It doesn't affect anything on the inside. They cancel. 2x minus 1 equals -2. Anything inside the bars yields a positive value. So when does a positive value equal -2? It doesn't, ever. So that's also no solution. All right, guys. Thanks for checking this out. Maybe I kind of rushed the concepts on this, but hopefully on Friday and on Monday, I can explain this well enough to where you guys are like, I think I get this now. All right, see ya.